What we are going to discuss now is about civil engineering subdisciplines. There are 13 subdisciplines. One is coastal engineering. Then we have construction engineering, earthquake engineering, environmental engineering, forensic engineering, geotechnical engineering, material science and engineering, site development and planning, structural engineering, surveying, or what is termed as geodetic engineering, transportation engineering, municipal or urban engineering, then water resources engineering. With coastal engineering, we have a subdiscipline that is concerned with managing coastal areas. In some jurisdictions, the terms sea defense and coastal protection mean defense against flooding and erosion, respectively. The term coastal defense is the more traditional term, but coastal management has become more popular as the field has expanded to techniques that allow erosion to claim land. In this photo, you can see the Palm Jumeirah waterfront development in Dubai. Now, with the construction engineering, it involves planning, execution, transportation of materials, site development based on hydraulic, environmental, structural, and geotechnical engineering. As construction firms tend to have higher business risk other than the usual construction engineering services, then construction firms tend to do or engage in business-like transactions, for example, drafting and reviewing contracts, evaluating logistical operations, and monitoring prices of supplies. So if, for example, you are an owner of a construction firm, but you are not yet confident to take the risk of what these big construction firms has been offering with their services, then you can start offering services in like drafting or evaluation or monitoring of prices and supplies. Then earthquake engineering, it involves designing structures to withstand hazardous earthquake exposures, and this is the subdiscipline which is also known as a subdiscipline of structural engineering. The main objectives of earthquake engineering are to understand interaction of structures on the shaky ground, to foresee the consequences of possible earthquakes, and to design, construct, and maintain structures to perform at earthquake in compliance with building codes. That is why in your other subjects, you are also studying the building codes in relation to earthquake design. And in this photo, you can see a simulation of the structures in a laboratory to check if this structure can withstand a certain earthquake intensity. Now, with the environmental engineering is the contemporary term for sanitary engineering, though sanitary engineering traditionally had not included much of the hazardous waste management and environmental remediation work covered by environmental engineering. Public health engineering and environmental health engineering are other terms being used. And it deals with treatment of chemical, biological, or thermal wastes, purification of water and air, and remediation of contaminated sites after waste disposal of accidental communication. Now, with forensic engineering, it is the investigation of materials, products, structures, or components that fail or do not operate or function as intended, causing personal injury or damage to property. The consequences of failure are dealt with by the law product liability. The subject is applied most commonly in civil law cases, although it may be of use in criminal law cases. Now, with civil engineering subdiscipline, which is termed as geotechnical engineering, then it studies rock and soil, supporting civil engineering systems. Knowledge from the field of soil science, materials science, mechanics, and hydraulics is applied to safely and economically design foundations, retaining walls, and other structures. Identification of soil properties present challenges to geotechnical engineers. Now, with material science and engineering, material science is closely related to civil engineering. It studies fundamental characteristics of materials and deals with ceramics such as concrete and mixed asphalt concrete, strong metals such as aluminum and steel, and thermosetting polymers, including polymethyl methacrylate or PMMA and carbon fibers. So this is a subdiscipline wherein if you want to make more a new product, for example, concrete hollow blocks, and the original components of concrete hollow blocks are only cement, sand, and water. However, if you will apply material engineering into that and produce a new product, then you can incorporate it with a new raw material, which could be a fiber coming from a waste agricultural product. For example, banana leaves, shredded banana leaves incorporating into the original components of the concrete hollow blocks. Then, as for the site development and planning, site development, also known as site planning, is focused on the planning and development potential of a site, as well as addressing possible impacts from permitting issues and environmental challenges. And for structural engineering is concerned with the structural design and structural analysis of buildings, bridges, towers, flyovers or overpasses, tunnels, offshore structures like oil and gas fields in the sea, aerostructure, and other structures. This involves identifying the loads which act upon a structure and the forces and stresses which arise within the structure due to those loads, and then designing the structure to successfully support and resist those loads. And with our current software, we are using STAAD in doing the structural design and analysis. As with surveying, or what is also termed as geodetic engineering, is a process by which the surveyor or geodetic engineer measures certain dimensions that occur on or near the surface of the earth. Surveying equipment such as levels and theodolites are used for accurate measurement of angular deviation, horizontal, vertical, and slope distances. With computerization, electronic distance measurement or EDM, total stations, GPS surveying, and laser scanning have to a large extent supplanted traditional instruments. And with this new technological advancement, it is also giving more accurate reading compared to the traditional instruments. instruments of surveying. Now, with the transportation engineering, it is concerned with moving people and goods efficiently, safely, and in a manner conducive to a vibrant community. This involves specifying, designing, constructing, and maintaining transportation infrastructure, which includes streets, canals, highways, rail systems, airports, ports, and mass transit. So this is applicable in highly urbanized locations or in big cities. Now with municipal or urban engineering, it is concerned with municipal infrastructure, and it involves specifying, designing, constructing, and maintaining streets, sidewalks, water supply networks, sewers, street lighting, municipal solid waste management and disposal, storage depot for various bulk materials used for maintenance and public works such as salt, sand, etc., and public parks and recycling infrastructure. And with the last subdiscipline, which is water resources engineering, it is concerned with the collection and management of water as a natural resource. As a discipline, it therefore combines elements of hydrology, environmental science, meteorology, conservation, and resource management. This area of civil engineering relates to the prediction and management of both the quality and the quantity of water in both ground, underground, which we consider as aquifers, and above ground, which we commonly known as lakes, rivers, and streams, as the resources for our next discussion. You can check on our next topic. So we have to end right here for now.